Alright, welcome back to the class. Now we will talk about rock deformation. There are two types of rock deformation, brittle deformation and ductile deformation. Brittle deformation, first let's look at the definition of deformation. Deformation is when there is a change in shape, position or orientation of a rock mass. So whenever there is any such changes in the shape, position or orientation of a rock mass, we will call it a deformation. Bending and breaking occurs when a stress exceeds a strength. So a stress, whenever we apply external force, that will induce a stress inside the rock mass, and whenever that stress will exceed the strength of the rock, then some bending and breaking will occur. So that is where when the deformation will happen, whenever the stress will exceed the strength of the rock. So two types of deformation, brittle deformation and ductile deformation. Brittle deformation, when an object shatter into smaller pieces. So think about a piece of glass. If you drop it on the floor, it will just shatter into smaller pieces. So that is kind of a brittle deformation. And same thing, if you hit a rock hard enough with a hammer, or if you throw a rock against a wall, chances are that rock will break into smaller pieces. So that is called as brittle deformation. And another one is ductile deformation, where a rock will not break into smaller pieces, but under applied force or stress, it will stretch into layers. So that is called as ductile deformation. I will try to explain it with an example of a chocolate bar. So think about a chocolate bar. If it is cold, then and if you drop that chocolate bar, or if you smack it against the wall, it will break into smaller pieces. Now think about the same chocolate bar. If you put it in a microwave and heat it for about 30-40 seconds, then it will become softer, right? And then if you stretch that chocolate bar after heating it, then it will stretch into thinner sheet. It's become thinner, it will stretch longer. So that is called as a ductile deformation, where you can stretch a material into a thinner layer. And think about the rock. I mean, it's hard to imagine that how rock can be stretched in a layer, because it seems that rock is such a strong, cohesive material that it's very difficult to imagine. But think about again the rock which is buried deeper in the volume, in the body of the earth, where the temperature continues to grow as you go deeper in the earth layer, right? So that heat, geothermal heat, will work just like what microwave does to the chocolate bar. It will continue to soften the rock, and the rock, as it is undergo external stress or pressure, then it will stretch in the form of a layer. So that is how a rock can undergo either a brittle deformation or ductile deformation. So just by using my example of chocolate bar, you can imagine the brittle deformation will only occur in a cooler environment, where near the surface of the earth, not only in the polar region, but also in the equatorial region, or anywhere on the surface of the earth. The brittle deformation will occur near the surface of the earth, whereas the ductile deformation will occur deeper in the layer and deeper in the volume of the earth. So as the rock is buried deeper in the earth, it will be exposed to geothermal heat, and that will soften the rock, and that whenever the stress is applied on this rock, it will stretch into layers. So that is called as ductile deformation. Here is one example. You can see this is an exposed rock now. This is but you can see there is a bending in the rock. You can see a very distinct this kind of a wave-like structure here, and that is called as a fold in the rock. And this is again a kind of a ductile deformation, because the rock did not shatter into smaller pieces. It just deformed its shape, just like a chocolate bar. If you heat it and then you can fold it, right? But if it is not hot, if it is not softened, then if you try to twist it, it will just break into smaller pieces. So that is the difference here between brittle deformation and ductile deformation. So now we will look at these different terms that comes into fold. Okay, so now let's look into elastic deformation. This is another term related to deformation in the rock. Elastic deformation is a type of deformation which can recover its original shape after stress is removed. So stress is gradually applied. You can think about overburden pressure, since due by means of erosion and other geological event, more and more mass are deposited on top of the surface. So the rock underneath will continue to experience higher and higher overburden pressure, and this stress is gradually applied. So it will apply some pressure or stress on the underlying rock mass, and that will try to squeeze that. And whenever that overburden pressure is released, the rock will recover its original shape or original width or thickness. Whereas whenever this elastic limit, so there is an elastic limit in every material, so it can deform in that elastic limit, and as soon as the stress is released, it can recover its original position. So that is that elastic limit, that a material can undergo deformation to a certain extent, and it can recover its original shape and size after the stress is removed from that object. So that is a elastic limit, and whenever that elastic limit is surpassed, and the deformation will then become permanent. So that is called as a ductile deformation or brittle deformation, where the deformation become permanent, whereas the elastic deformation is a deformation which is not permanent, it is only temporary, and that deformation will go away as soon as the stress is removed. Strength of a rock is influenced by temperature, confining pressure, rock type, and time. So these are the factors. I want you guys to remember these 4 factors which influence the strength of a rock, like temperature, confining pressure, rock type, and time. Temperature, like we discussed that example of putting a chocolate bar in a microwave oven and then heating it for a little bit. So that is how exactly the temperature will soften the rock, and it will change the strength of a rock. Confining pressure is another one. When confining pressure is applied, rock experiences a stress, and then its strength will be tested. So beyond a certain limit, it will start undergoing deformation, and then this deformation can surpass the elastic limit, and then it will become a permanent deformation. Type of rock, again, that is another important factor. What are the minerals present in this rock? What type of bonding is present in the minerals? So that will control the strength of the rock, how strong the rock itself is, and the time, how long the stress or the external force, overburden pressure has been applied. That's another factor that is going to influence the deformation or the nature of deformation experienced by a rock. Brittle deformation, ductile deformation, these are the features of these different deformation. Brittle deformation, it results in fractures. Once again, think about the chocolate bar. When it is cold, and if you hit on it on the surface, if it doesn't break, at least you will see some fracture forming on the rock, and if you hit it few more times, then it will break into smaller pieces. That is ductile deformation. So it starts with a fracture, and then the fracture will grow, and the object will fall into smaller pieces. Ductile deformation, it is a solid state flow at greater depths. So this happens at in a deeper environment where geothermal temperature is relatively high. It's a hot environment that will try to soften the rock. It produces a change in the shape and size of a rock. So as we saw earlier, that folding example where the shape and size of the rock changes, some chemical bonds may break and new ones will form. Because the layer, as it is being stretched, pulled apart, the minerals will start forming and breaking new bonds, chemical bonds. What is brittle deformation? Just a definition here: fracturing of rock when the elastic limit of a rock is surpassed. That occurs at or near the surface. So the important point here to remember is that brittle deformation occurs near the surface, and ductile deformation occurs at a depth where geothermal energy is high and the temperature is higher relative to the surface. What are the major types of folds? So the folds are a type of ductile deformation, right? So in this case, folds are wave-like undulations that form when rocks bend under compression. So again, another important point here is compression. Folds occur only when there is a compressive stress is applied. So suppose this is your block of rock, and compressive force is like when something is pushed inwards, and it is compressed inwards, so that is called as a compressive force, and that is when you will see the rock will start compressing like this. So if suppose this is your new width of the rock, so then it will have some kind of wave-like undulations, and that is called as a brittle deformation here. And compressional forces result in shortening and thickening of the crust. So this is another important distinction between brittle deformation and ductile deformation. In the case of brittle deformation, if you look at this same rock mass, this will be stretched like this. So there will be a thinning of the layer. So you can think again about that chocolate bar. If you stretch it, if there is ductile deformation, then there will be a thinning of the layer. Whereas in the case of compressional force, there will be a thickening of the crust. Folds. These are 5-6 different types of folds. I will just draw some pictures here to make it clear what are these different types of folds. So first one is anticline. So this is that fold. So right, this is what it looks like when it is warped upside. So this curves upside, then it is called as anticline. And when it warps downwards, then it is called as syncline. So here anticline is easy to remember because it looks a lot like a letter A. Syncline looks like S in a way, so you can remember that. Anticline, it warps upwards. Syncline, it warps downwards. So the bending, the wave-like formation is upward or downward. So that is how it changes. So symmetrical is another one when I can think about it like this. So you can think this is, so they are symmetrical. The legs here or the limbs are symmetrical to each other. It's like a mirror image. On the other hand, asymmetrical is where you have one limb is stretched or has a different inclination. If you think about this angle, they are a different angle. So that is how this asymmetrical will look like. And symmetrical, if you look at this axis, right, where it can be divided into two parts, so they are like a mirror image, whereas these two are not mirror image. So those are called as asymmetrical folds. Another one is overturned. So this is the case where one limb is like this, little bit over the another one, right? Okay, so this is called as overturn, where you can look at this axis is no longer vertical. Like in these cases the axis is vertical, but here now the axis is no longer vertical. So this is called as overturned case. Right. And then there is another one which is called as recumbent, in which it is like the layer is almost laying on top of the other one. Right. This is what it is. It is the axis is, the angle is much smaller at which the angle of inclination, right? So this one is called as recumbent, and recumbent just simply means laying down. And so this is what it looks like, that due to this compressional force, this one rock mass is completely overlying on this other rock mass. So this one is called as recumbent folding. So these different kinds of foldings: anticline, syncline, symmetrical, asymmetrical, recumbent, or overturned folding. So here in the case of recumbent, axis is almost horizontal, overturned. One or both limbs are tinted beyond the vertical. So make sure that you remember these definitions. Anticlines are upfolds or arched layers, syncline associated downfolds or troughs. Then there are some which are called as domes, where your axis is not exactly vertical, but in this case so it will be more like this. If you can imagine a hat, so this is what it will look like. Fold. So if you have compressional force from all sides, then it will become more like a circular hat-like structure. Okay. And it is dome, so it is upward. I can't draw a three-dimensional picture here, but there's a photo in your textbook that shows what a dome looks like. So it is like literally it looks like a dome, elevated structure in the middle, and it has a slope on the side. It is and basin is so it is increasing the elevation in this direction, right? Basin is also, if you draw the top view, it is the same. It's just that it has a depression in the middle, so it is all the elevation is decreasing downwards in this direction, right? So this is they both, from the top view it looks the same, but if you think about it in three-dimensional view, the dome is increasing in the toward the center, the elevation. The basin, it has a depression in the middle. So the dome is more like a upwarp or anticline, and basin is more like a syncline, where you have a depression in the middle. Here are some of the photographs. This one is anticline, it has an upwarp. Syncline, it is a downwarping. This is more like an overturned fold. It is not all the way flat. If it was flat, then we would call it a recumbent fold. So these are again some of the geological features that you can see: anticline, syncline, and then overturned limb. What are the major types of folds? Anticline, syncline, overturned, and recumbent. Make sure you remember these 4 different types of folds, maybe in your exam. Now we will talk about faults, strike slip faults.